Hi everyone and welcome to this tutorial. Today I'm gonna give you a masterclass on Arduino simulation and Arduino programming. This video is a bit long, but it is important to take time to understand things properly. Sometimes you want to learn electronics, Arduino, and programming, but it is difficult to have money or enough to buy components. Or sometimes it takes long to be delivered at your home in certain regions of Africa, Asia, South America, and even in developed countries. And even when you have hardware, or when you want to buy SAMs, you want to avoid damaging them, or you want to avoid, uh, or you don't want to buy companies that you are not going to use in your project. So making simulation in online platforms save you both money and times. There are several apps and online platform simulation in the world, like Phrasing, Tinkercad, Wiki, Proteus, etc., etc. But in this video, we're gonna focus on Tinkercad. This course covers project building, Arduino programming, and project simulation in Tinkercad. We're gonna see what are the best practices on how to avoid common mistakes. So we're gonna see what is Tinkercad, how the platform look like, how to build projects on this platform, and how to use it. We're gonna build project steps by step. We start by basic ones, beginner project, intermediate, advanced, and expert or engineering level. Well, what is Tinkercad and how does the platform work? Arduino and Tinkercad are very popular in the world of engineering, electronic, and circuit building. It is used by hobbyists and professionals, but many people still don't know those platforms or hardwares. To come back on the definition of Arduino, Arduino is an open source electronics platform uh, where we can build and create circuits or projects. Uh, we use Arduino for programming microcontroller and devices like motors, sensors, LEDs, and many other hardwares. Arduino exists in many types. There are Uno, Nano, and Mega. Arduino support many languages like C, C++, and Python. We can also build small AI projects with that small microcontroller. Uh, Tinkercad, Tinkercad, what is it? Tinkercad is an online platform using for design and simulation. We can build threaded circuit and make a project prototype and make a prototype projects. It is used for educational purpose to teach lesson, and when you have project ideas, uh you can build your project on Tinkercad to see at first how to manage your project. Both Arduino and Tinkercad are transforming the world of electronics and engineering. Uh, Inside Tinkercad, there is a platform where it is called Tinkercad Circuit. It is a simple drag and drop interface for design circuits. It includes electronic library and components. We can make connection between those components. This platform supports C, C++, JavaScript, and Python languages. We can exchange data. This means that we can upload and download data from this platform. And viewers, Tinkercad is used for designing and simulating circuits. It is user-friendly platforms and include many components. Now, let's leave too much talk and go pricing. Open a browser and tap Tinkercad. Click on the first link here. Well, uh, don't worry, I will put the link on the descriptions of the video. Once you are on the platform, you need to create an account. So click on Sign Up, create a personal account, register with an email. Well, a form appears here. Please fill it up, and continue creating your account. Uh, I will stop here because I have already created my account, but you need to go until the creation of your account. Very good. You are on the platform. Before I describe you the platform, I need to show you quickly something. Click on Circuits, choose a battery, uh, rotate it with the button on the top menu here. Rotate. Okay, very good. Let's add an LED on the circuit. Connect the short leg of the LED to the GND negative part, and the long leg of the LED to positive. Change the color of the LED. Red. The negative one is black. Click on Start Simulation. Well, uh, let me zoom. Let me zoom with my mouse wheel. As you can see, the LED is turned on, but there is something more dangerous here. There is a warning in the platform. This is why it is also uh, important to use a platform simulation to see the dangers. Yeah, we see that there is a warning on the circuit. Why? It is probably because we didn't use a resistor to protect or to limit the current on our LED. So to correct this stop simulation, okay, we delete this line with jumper wires, please. Add a resistor, okay, and then okay, change the color to white, white. Start again, simulation. Very good. The warning disappeared. So, to come up or to summarize, you have to keep in mind that if you want to avoid damaging your hardware or your components or your sensors, you need sometimes to add many resistors on your project. It will avail you it will avail you to lose time and will allow you to save money. So stop simulation. If you want to go back on the home page, please, on the top left corner, click on the Tinkercad logo. Well, this is the platform of the Tinkercad, and as you can see, the project that we have, the small project that we have built is stop is registered here. Okay, but I will let me explain you how the platform look like. At the top you have at home. You can see many things that you have done before. Uh, it's 3D design. Here is a drone. Your circuits and a code blocks. You can also join a class. You can join a class, or you can also you can also transfer a design that you built. You can also design circuits. This is what we have done previously. You can create your own collection. Okay, you can follow tutorials here, or you can enroll for a challenges. So in this tutorial, we'll focus on designs. Well, on the top, on the top right of the corner, on the top right corner, click on Create. When you create on this button, you see three options: 3D design, circuits, and code blocks. Click on circuits and the workspace open. This is where you're gonna build your basic, beginner, intermediate, and advanced projects. But before doing anything, let me show you something more again. On the top right corner, click on components. You have many options here. Click on Arduino, and you have many projects that are already built in the platforms. Okay, come up again. Uh, all. Uh, uh, Select an Arduino. Put it on the workspace. Drag and drop. Yes, this is very well. Drag and drop. Click on Start Simulation. Very good. Let me zoom it with my mouse wheel. Well, there is an LED blinking here on the Arduino. This is mean that Arduino has an LED already incorporated in the board. This allows us to make quick tests before doing any or building any project to test if the Arduino is still working. Stop simulation. Let's try something more. Okay. Uh, okay, leave this. Okay. Now we're gonna make something very easy. Click on Arduino. Choose a project which consists of blink an LED. Put it on the drag and drop and put it on the workspace. Well, to simulate your project, again, don't forget, click on Start Simulation. Very good. And the LED is blinking, as you can see. To stop the simulation, click on Stop Simulation. Well, let me describe you a little bit more the LED. The LED has two like the short LED, which is the cathode of the negative leg, and the long leg, which is the anode of the positive leg. You can change the color of jumper wires here. Wires. You can also change the resistor. For example, I can change. I can say I want to 1,000 uh 1,000 ohm. Okay, so 1,000 kilo ohm. As well as you can see, the color of the printed on the resistor have changed. Let's try again something. Put 2 enter the color change. 4 uh 4 enter at 5, for example. Let's say 47. The color has changed. Very good. So you can change the color of your resistor. Okay, very good. Let's delete this and try something more smarter. Okay, okay, delete this and delete this. And we're going to fade an LED. So on the list here, choose fade LED. Fading an LED is a project which is widely used for brightness in many projects. We can use it to control brightness in the room, and control also brightness dimmer on your room. Okay. Start. Click on Start Simulation. The fading LEDs look like so blink an LED, but not exactly. And as you can see, when you simulate the process, the LED turn off progressively, but not totally. It doesn't it doesn't on, turn off, sorry, totally. But this is a fading an LED. Stop simulation and try something more. Okay. What we're gonna do right now is how to see how to use a push button. Search for search button. Yes. Drag and drop it. Start simulation. Let's press. Yes, let's press the button, the push button. Wait, let me zoom with my mouse. Wait, release it. Zoom again. Wait, press the push button. As well as press the push button, the LED of the Arduino is turned on. And when I release the push button, the LED turns off. Again, press the push button, the LED turns off. Turn on, sorry, and release it, the LED turn on. Turn off, sorry. Let me come again. Press the push button, the LED turn on, and release the push button, the LED turn off. Okay, stop the simulation. Let's try something more again. Debounce. Debounce is how to use again a push button that's opposite to the previous one. We don't need to press long or for many times the push button. Click on start simulation. Okay, right. The LED of the Arduino is turned on. When I click on the push button, the LED turn off. Click again on the push button, the LED turn on. Click on the push button, the LED turn off. Very good. Let's add something more on the push button circuit. On the push button circuit, on. Add a an LED on the circuit. Drag and drop. Uh, uh, let's add a resistor for best practice. Okay. Connect it here. This is the TND, so we need to use the black color and connect the long leg of the LED to a pin of fairing. Okay, change the color again. Click on start simulation. When the LED is turned on, click on the push button. The LED turn off. Click turn on. Click turn off. So you can play with that to see how the circuits work. So stop simulation. If you want to see how the circuits or how the projects work, click on code. And here you have a text, a blocks. Click on blocks. Continue. Well, on the here is a code blocks. It is a no code. You don't need to know any programming languages, any programming language um, before starting building with no code, with code blocks. You can also see both the code block and the program. Okay, or you can just only see the code if you want. Here, for those who have an intermediate level or an advanced, they can just use the code. Okay. Let's delete this. Yes, delete this. I'm sorry. Delete, delete. Mm, let's try something more, please. Okay. how to print, yes, how to print on a screen. Uh, LCD, drag and drop, and click on start simulation. Well, very good. There is a sentence printed on the LED or on the screen. It is written hello world, and we can see also a timer here. To see what is happening on your circuit, please stop simulation at first. Code and uh, here click on a blocking test. Yes, here the hello world printed on the screen is written here. If you want to see what could happen if you change, please you can write something like good morning, and start a simulation. Well, good morning is printed in on the screen as you can see here. You can also see more things. When you print good morning here, the code is automatically generated on the text here. But you can also just modify the code for do more little more keywords. So right here, uh, I love, for example, I love you, I love you, and so a simulation. Well, as you can see, I love you is written on the LCD on the screen. Very good. Stop simulation. Let's try something more. How to measure soil moisture. Okay. Uh, let's delete this project. So okay, very good. Go for moisture. Okay, moisture. Uh, uh, moisture. Moisture sensor. Moisture project includes a moisture sensor. This allows us to measure soil moisture. It is widely in research field to measure dryness of the soil, the dryness of the soil. So start simulation. Click here. When the LED is red, this means that the soil is so much dry. But when you are on the blue LED, you can see that the soil is wet. We can see it's wet. On green, the dryness of the soil is a little bit normal. Okay, very good. Stop simulation. Let's this project. Let's go for another one. Activity. Activity. I mean, activity is a project used for uh, advertisement displays. It is also used on Christmas Day for holidays and also for parties. Well, this is at all. As you can see, there are many LED on the hardware, and we have many colors and animations here. Stop simulation. Let's try some things. Mm, when we can choose here? Ah, voltmeter. Voltmeter, in simple words, it is a project used to measure electrical signals. Okay, start simulation. As you can see, the voltage is printed on a screen, and also the current. Stop simulation. Choose again. Infrared receiver. Wait, infrared receiver is a big project, and it is used in many fields like hospital appliance, and also it is used to control wireless devices. Start simulation. Click on any button you want. Okay, very good. Stop simulation. Ah, sorry, I forgot to tell you that you can change the name of your circuit. So on the top left corner, click on and you can write some things that uh, first basic simulation. Enter. To go back on the home page, don't forget on the top left corner, you can click on the Tinkercad logo. Click on. Yes, you come back on the platform. Uh, Here, your circuit is saved here. You can delete the circuit, add to your collection, view history of your circuit. You can also duplicate the circuit or click on properties. This allows you to change the name of the circuit, to make a small description, and also add a tag. So concern when I think this is all for how to use project already available on the platforms. Now we're going to build ours step by step. We're going to start with the basic ones and show you how to use code blocks. Let's learn how to blink an LED on Autodesk Tinkercad platform. Click on Create, Circuits. Well, first of all, change the name of your project, Blink, single, Blink single, LED, enter. Well, drag and drop a resistor, drag and drop an LED, drag and drop a resistor. Well, connect the short leg of the LED to the GND of the Arduino through the resistor. Okay. Change the color black here. Connect the long LED via node of the LED to pin number 13 uh, of the Arduino. Change the color white. Very good. You can also change the value of the resistor. Let's choose here 220 ohms. Yeah. Click on codes to make your block code. There is a block code already available here to blink an LED, but we're gonna do ourselves. We're gonna do it ourselves. So move this. Well, um, choose of however, we need an output. We need an output pin. So set pin. Set pin here. Choose set pin. Um, Pin number 13, and we bring 5 volt to the we bring 5 volt from the Arduino to the LED. So we let it here as high. Again, control. We need to wait some seconds before going for the another steps. Wait, for example, 1 second. Then add again an set pin. Sorry. Uh, Set pin. No, sorry. Again. Low. Okay. Uh, Wait. Now, we can also put comments on our project. Here, oh sorry, here we turn on. the LED. On here, we turn down, so we turn off the LED. Well, uh, to so click on Start Simulation. Oh, very good. As you can see, the LED is blinking. Is blinking. It's turned on for 1,000 milliseconds and turned off for another 1,000 milliseconds, and the process repeat again. That's why in the code we have for repair. So if we want to stop the simulation, we can click Stop Simulation here. Well, change also the value because 1,000 milliseconds is so much. We can say that we want to blink the LED, for example. Oh, let's choose 200, 200 milliseconds. Uh, yes, 200 milliseconds. Code start simulation. Well, and the LED is blinking faster than previously. Well, this is how to blink an LED using code block on Autodesk Tinkercad platform. Click on Stop Simulation. Let's learn how to fade an LED. Okay, right. Click on Create Circuits. Mm. Well, drag and drop. And as you know, drag and drop a breadboard. Okay. Well, connect at first the GND and the 5 volts to your breadboard. Right. This is the GND, right? This is the 5 volts. Let's change the color. The black one, the negative, the GND. Let's do the same things. Okay. Right. Doing this at first is one of the best practices when you are building a project or Tinkercad, because it will save you times and will save you um this is a strategy, okay? Right. Oh, right. Black. Let's change this. White. Drag and drop an LED. Drag and drop. Drag and drop an LED, and drag and drop a resistor. 5 volts. So let's choose digital pin number 9. Okay. You can also change the color. Here, we can choose the green one. Open the code block. Delete those code block. Delete this. Well, we're gonna start by creating a variable. Let's say brightness. After that, go to control, select a counter. Well, set pin, choose an output set pin, set pin 3, set pin, choose this pin, set pin. add your brightness, right? Rename this brightness. Start by uh, yes, it's 5 from 0 to 255. Uh, Raise, we can say that for 50 seconds, 50 milliseconds, sorry, 50 milliseconds. Duplicate this block and put here. We're going to do the same things, but we reverse the procedures by changing numbers. Here is 255, 0. Sorry, we forgotten to choose the pin number. It's none here. Here, it is none. Okay, very good. Um, let's check if everything is okay. Brightness, millisecond, very good. Close and start the simulation. Let me zoom with my mouse wheel. Can you see the brightness of the LED is brightening? Can you see the brightness of the LED? It's a bit faster, but if you pay much more attention to the LED, I think you can see the changes very well. So this is all for how to fit an LED. Sorry, we forgot to change the name of our project. So uh, Fet LED. Stop the simulation and go to home page. Well, since now we have just created two projects, blink sync LED and fade and LED. Let's learn how to play multiple LED. This is the third project of our beginner level Arduino simulation on Tinkercad. So click on Create Circuits, change the name of your project. Here, blink multiple LEDs in turn. Drag and drop an Arduino. The same things with a breadboard. First of all, connect two things. The GND of the Arduino to a minus way of the breadboard. And the 5 volt of the Arduino to the plus way of the breadboard, two-way plus way of the breadboard. Let's change, do the same thing for the other side of the breadboard. Okay. Let's change the colors. Here is black for GND, black for GND, and red for the 5 volts. Red for the 5 volts. The second step is to add 3 LEDs. 1, 2, and 3. Let's change the color. Here is we're gonna leave it to to red. The second one is green. And the third is blue. Fine. Let's add LEDs to not fire. Sorry, let's add a resistor to not fire any LED. This is not correct. Okay. After that, let's connect each long length of the LED to Arduino. Yes, it is. Sync, change the color to the same as the LED, and this is for pin number 11, blue. Okay. After that, let's go for code block. Click on code. Okay. Let's move those blocks. Control for river. Let's create a variable. This is time animation, because we want to blink the LEDs at some regular times. Set set the animation, the time of animation to, for example, 500 milliseconds. Set pin number 30 to high to high, and set so wait, I'm going to say the time of animation, this is millisecond, don't forget that. Set again pin number 13 to low, wait, the time of animations, milliseconds, duplicate those blocks. Make the same thing again. Very good. Let's change the pin. This is pin 12, pin 12, pin 11, pin 11. Very good. We have done with this. Let's go for the simulation part. Click on Start a simulation. Well, as you can see, the LED are blinking for a respective time. This corresponds to the animation time. We can add we can add more LEDs as we want. Let's add, for example, 2 more LEDs. Okay. Here, let's change the color. You're going to say, for example, this is yellow. This is this is orange. Okay. No, this is okay. Orange. Orange could be better. Okay. What we need to do is very simple. Is to duplicate, yes, this block. Duplicate also this block. And put this block here. Okay, right. This is very low. This is sorry. Connect. Yeah, don't forget that. Okay. Pin number 10. This is the yellow pin. Number 9. This is the blue. Okay. Code block. So this is pin number 10. Pin number 10 on pin number 9. This is pin number 9. Okay. Let's start the simulation again. Once the project works as well as we want. So you can add, remember, enough LEDs that we want. Okay, so this is all for this project on how to blink multiple LED. See you soon for the next project. Let's learn how to turn on and off an LED using a push button on Autodesk Tinkercad. Click on Create Circuits. Give a name to your project. Turn on. Turn on off LED with a push button. Okay, push button. Enter. Very good. First of all, let me show you quickly something. Click on Basic, Arduino, pattern. Click on Start Simulation. I'm going to show you quickly some things. Okay. Let me zoom with my mouse wheel. Well, as you can see, when I press the push button, the LED of the Arduino is turned on. And when I release the push button, the LED of the Arduino is turned off. This means that when I press the push button, I bring 5 volts to the LED from the Arduino. This means that we're going to see if the state of the button is equal to high, or if the state of the button is equal to low. This means that we're going to make a comparison between the state of the button and the state of the LED. Okay, I will start the simulation. So delete this. Well, drag an Arduino on the breadboard, on the workspace. Sorry, drag an Arduino on the workspace. Where is the Arduino board? Yes. Add a breadboard, the small one. Always connect the GND. The minus wheel of the breadboard and the 5 volts of the Arduino to the red post of the breadboard. Do the same things with the other side of the breadboard. This is one of the best practice. So change the color. The minus way is the black GND, and the plus is the 5 volt of the Arduino. Same things here. Red, and this is black. Drag an LED on the breadboard. uh, where's the LED? Drag an LED on the breadboard. Drag a resistor. Connect it to the short leg of the LED. Connect a jumper wire from the long leg of the LED to to digital pin number 13. Change the color of the jumper wire. This is red. Well, add a push button of a circuit like this. Okay. Add a resistor. Okay. Let's change the value of resistor. We're going to say 15,000 kilo ohm. Okay. Here is the 5 volt of the LED. I think this is okay. Okay. As we're going to press the push button and release it, I think it is better to add some things to see the voltage of the resistor or the voltage of the push button and some things else. Let's add a voltage, sorry, search here a voltage, sorry, a voltage to the circuit. Sorry, I've forgotten something. Here is the we're going to connect this leg to digital pin number 2. We change the color to green. This is for the GND, and this is for let's change the color to red, and this color the GND one to black. Very good. As the circuit is set up, I think everything is well. Let's go for the code block. Let's move this. Okay, we move to the bin. Right. Let's add. Let's give a title. Add some comment. We give a title to the code or to the project. This is the purpose of the aim. This project is to learn how to turn on or off an LED using a push button. Insert. Okay. Go and add a control block from here, for example. Add another comment line. As I showed you, we're going to read the state of a push button. So read the push button state, the push button state. Insert create a variable which corresponds to state the state of push button. Until set state of a push button, we're going to initialize it to digital pin 2. So as you know, when we press the push button, we give a signal to the circuit. So let's add an input we set it to digital pin 2. Let's add another comment here. We're going to do what? We're going to press to check if the push button is pressed or is not. So check if push push button is pressed or not. Enter. Okay, fine. The next thing that we're gonna do is to add a control, a loop, sorry, a condition, and a if else statement. As I told you, we're going to make a comparison. If a push, if when we, if the state of a push button is equal to high or is equal to or to low, so add a math control. We're going to read the button state. We're going to make a comparison if it is equal to to the high level. Then if this is equal to high level, we read uh we set we set pin we set pin number 13. We set pin number 13 to high level. Otherwise, we set pin number 13 to a low level. Okay, to a low level. Fine. Uh, After making the code, verify if everything is okay or fine, and let's go for the simulation part. Click on Start Simulation. Wait. At first, we didn't press the push button, so the voltage indicates 0 volt. When we press the push button, the LED is turned on, and the voltage indicates 5 volt. When we release it, it comes to 0 volt. When you press it again, the voltage indicates 5 volt. So the 5 volt means that we take 5 volt from the Arduino and we bring it to the LED through the push button. I think you you could understand this. It's not uh, so difficult at all. So when we release the push button, it is 0 now. Press it again. 5 volt. You can play with it at home or when you have enough time to see what's going on. So start the simulation. This is our fourth project on which consists to turn on and off an Arduino using a push button. See you soon to the next video. And this time we're gonna use another input hardware. This is a sensor. Its name is a potentiometer. It will allow us to turn on and off an LED by increasing or decreasing the brightness of the LED. So click on create circuits. Uh, Rename your project LED on potentiometer. Enter. Drag and grab quickly an Arduino and a breadboard, of course. Uh, don't forget this. Again, this. This is really important. You don't forget that. Okay. It is not nice at all. Yes. Cool. uh, this two pulse and this to the minus wheel. Change the color, black, red, sorry, this is red, and this is obviously black. Drag an LED, a resistor, the short leg of the LED connected to the red one of the breadboard of the Arduino. Add a potentiometer, sorry, add a potentiometer. Connect, this is what? Terminal wiper. Okay. We connect this part to the GND. This is for the 5 volts. Okay. This is for the 5 volts, and this we're going to connect it to something new. We're going to use the analog output or input of the Arduino. Since now we used to use the digital the digital pin, but in this project we're going to use the uh, we're going to use the analog pin. Okay, what's the difference between the digital pin on the analog pin? The digital pin takes just only two values, 0 volt or 5 volt, or 0 and 1. In the opposite way, the analog pin takes it is a float. It can take any value from 0 to 5 volt. It could be 2.5, 2.8, 3.8, 3.5 to 5 volt. Okay, let me show you quickly what a potentiometer looks like in Arduino kits. Okay, image. Okay, this is how the the potentiometer looks like on an Arduino kits. Okay, this is a potentiometer. This is a potentiometer. So there are many types of potentiometer in an Arduino kit. You will probably find them in your kits if you had bought one. So come back to our Tinkercad. Right. We can add a voltage to our circuit. Sorry. Drag and drop. This is also change the color to the red one. And okay. Sorry. Okay. This is the GND. It is black. This is the 5 volts of the this is we connected with sorry, we connected to analog pin A0 to analog pin A0. Sorry, change the color. This is green. Well, once the circuit is set up, let's, oh sorry, we forgot something. We didn't connect the long LED of the LED. So we can jump away from the breadboard to uh digital pin number 13. Change the color to wait. Very good. Now as the circuit is set up, let's go from the code. Okay, so click on code, uh, remove this, on the bin. What's going on? Sorry. Uh, okay, let's move this on the bin. Same again. Right. First of all, we will use to add a title. Turn on. Turn on. On off. An LED with a potentiometer. Let's add. We're going to wait a value, from the potentiometer. So, we need to set a variable to the potentiometer pin. So we create a variable is going to potentiometer value, potentiometer value, sorry, potentiometer value. Enter. So set a potentiometer value. We're going to read the analog pin is 0. This is where we put the potentiometer legs. And after that, we're going to turn the LED on. So command turn on the LED, turn on the LED. We set the pin. We set now pin number 13 at first. Pin number 13 to high level. We make a pause. Make a pause to read the value. Make a pause. Enter. Wait. In milliseconds. And then turn the LED off. Turn the LED off. Now we're going to turn the LED off. So turn the LED off. Okay. So turn off the LED. Send it to digital pin number 13. Now we're going to assign the value of the LED to low. Then make a pause again. Make a pause again. Enter. And now wait again until we read the value of the potentiometer value. This is going to be a milliseconds. Don't forget to change that, because you're going to win for a while if you don't change the value of the if you don't change the value from second to milliseconds. There we go. You can also see the blocks and the code blocks. This is the code block written um, on C++. As I told you, the potentiometer is uh, is assigned to to an input value as we give signals to the circuit. So it is input. It is an input sensor, and we read the LED at pin number 13, and at pin number 13, this is an output. Very good. We can start the simulation part. Well, we can play with this value. It is 1000 millivolts. We can put it. You can see that the LED is blinking faster. Let me zoom with my mouse wheel. The LED blinks much faster. When we come here, it is faster that it seems that it didn't blink. It didn't blinking. We can uh, the speed of blinking become slow. This is slow. This is slow again, and this is very slow. So this is how to change the speed of the LED and how to turn it on and off using a potentiometer. I hope this project will be useful for you and that you're going to use it in the near future. So I advise you to reproduce this project step by step at home. Do it yourself, and you will be confident on how to use Autodesk Tinkercad to make your simulation. So let's go for the next project. Welcome back to the next project. In this project, we're going to see how to use an RGB LED to change color. So click on Create Circuits. The first thing that we're going to do, as you know, is to drag and drop quickly an Arduino and a breadboard. Connect that first, as usual, the GND very quickly to a minus way of the breadboard and replace the 5 volts to the plus way of the breadboard. We can change the color to red, and this is black. Do the same process here. This is sorry, this is yes, this is black, and this is red. This is red. And now drag and drop an RGB LED here. Add at least 3 resistors. This is on here. As you can see, this is the red pin. This is the cathode leg. You can connect it quickly to the GND. This is black. Very good. This is the blue leg. This is the green leg. So the red pin, the digital pin on number, let's say 11, the this is what, this is a blue pin. Let's change the color. This is red. The blue pin to generator pin number 10, and this is sorry, the blue pin, blue red, blue leg. This is for the generator pin number 9. This is absolutely green. Let me show you quickly what RGB color is. Tap on your browser RGB color. RGB color, as you can see, is three color. Red, green, and blue. In electronics, we don't have all the color that exists in the world, as you can see in the nature or in environment. But we use a technique to reproduce those colors in electronics or in computer devices or in software or any embedded device that you can see around you. So we can use those three colors to make any colors that we want in the world. There are a lot of techniques included in that process, but here we gonna to focus just only how to to let the RGB LED blinks take those different colors. We're not going to go deeper to explain everything, but make sure that in the following lessons we're going to learn uh, we're going to deepen this uh, in a tutorial. So okay, quickly. So click on code, move this to a bin. Again, move this to a bin. Okay. As we used to do, going to give a title to the project. Change RGB LEDs color. Change RGB LEDs color. Okay. And now we're going to set the third color. Set the first color. Enter. Don't worry, the platform has a block to that type of LED. So as you may know, we start by generator pin number 11. So generator pin number 11. After that, it is 10, and then 9. We add a control block. We want to wait for at least 1 second, and then we produce the same thing. You can duplicate this. Again, duplicate this. So instead of set the first color, we're going to say set color set the red color. Set the red color. We wait 1 millisecond. Then set the green sorry, the green color. Let's choose the green color here. After that, we wait 1 millisecond, then set the blue color. Set the blue. Set the blue color. This is the blue color. As the code is ready, we can start to simulate. Let me zoom. We start with the red, blue, and then the green. Red, green. We can stop simulation. We start with what? We start with red, green, and then blue. Start the simulation again. We start with the red, blue, and the green. Uh, stop here. The blue is set at GT top pin number 10. So this is not we can change the order. Okay, we can change, sorry, we can change the order if you want. Sorry, we can change the order. This is the last, so it is RJ. So red, after we have green, and then we have blue. Very good. So start the simulation again. This is green. Sorry, stop. This is red, green, blue, red, green, blue. Very good. So we can add something more on the code here. For example, we can repeat something for example, for 3, 4, 2, or 10 times. So we're going to add a repeat block. We want to repeat this block, for example, twice. Repeat this part. Repeat this. Repeat this twice. Enter. So twice. Duplicate this block. Oh, sorry. What we need is this is forbidden. This is also for okay, wait. This is also for here. Now, for the repeat block, we can say that we want to turn the LED to yellow. We wait 1 milliseconds and then turn it to let's say to maroon. Very good. Okay. Start the simulation. Yellow, maroon, yellow, maroon, and we start with okay, very good. So you can make a pause, reproduce this block at home, and then add something new to your code at home. Don't forget to enhance this project because this is way basic. And if you want to be more confident or or if you want to become if we want to have sorry, an intermediate level, you need to practice sometimes at home. This is not very hard at all. So keep going and you'll be better on Arduino simulation uh, using Autodesk Tinkercad. So see you next time for our next project. Well, someone told me that you are more proficient now on building a project and making Arduino simulation on Autodesk Tinkercad. Now we're going to make something more difficult than usual. We're going to build a panel. So go to your Autodesk Tinkercad platform, click on Create as Visual Circuits. Change the name of your project. This is panel. This is panel. Piano. Sorry. This is piano project. Okay. Piano project with what we push button. Enter. Quickly drag and drop a breadboard and an Arduino. This is an Arduino Uno. Connect the GND to the connect the GND. Connect the GND. Sorry. Quickly connect the GND. So the minus wheel of the breadboard. And then connect the 5 volt of the Arduino to the plus wheel of the breadboard. This is red, and the last one is black. We're going to do something unusual. We'll make this where we're going to connect it to the GND because we need a lot of place here. Drag and drop for push button quickly here. 1, 2, 3, and 4. Add a buzzer to hear the sound generated by the push button. Right, very good. Add 4 resistors. Connect them to the okay 1. Connect them to the push button and the GND that we created on the plus way. Now connect the positive, the 5 volt of each resistor to this is the red one with 5 volt. This is the 5 volt. This is of course the this is of course the 5 volt here. This is the 5 volt. Right. Connect each pin to this is we connect this to digital pin number 7. Let's change the color to pick. Connect this pin to digital pin number 6. This is the let's choose the color, the green. Connect this to digital pin number 5. This is the purple color, and connect the last push button to digital pin number 4. This is the green one, the green color. Now connect one leg of a bezel to digital pin number 2. Yes, we're going to change the color to orange. On connect the other leg of a bezel to the ground. This is black. Well, I think that all the circuit is really set up. Let's go for the code part. Click on card, move those things, most quickly those things. Okay, move these things. We're going to give a title to our project. This is beat piano, beat piano, beat piano, beat piano, beat piano by using for a push button on a bezel, enter. Okay. We're going to wait the state of the push button if it is pressed or if it is released. So we need to add an if statement to see if the button is pressed or not. So an if button and an if an if block. The second thing is to add a math control. So to add a math option, a math block, to see if the button is equal to the eye level or if it is equal to the learn level. So we need to add, we need to read the digital pin, the input pin. So read digital pin number, yes, we start by the number 7, read digital pin number 7, read the state of the push button. When the state of the push button is higher, we will play the we will play sorry the we will play the bezel, which is set to digital pin number 2. We want to hear for 60 milliseconds for with 0.1. What is going with my keyboard? 0.1. Okay, very good. We will repeat the same process. So the same process. So we duplicate this block. 1. We have 4 blocks. 2 and 4. Very good. Let's change the pin number. This is pin number 6. This is pin number 5, and this is pin number 4. I think yes. pin number 4, as you can see here. This is set to pin number 4. But we're going to change the sum of each of the bezel when we press on each push button. This is, for example, 105. 105. This is let's say that 100. So it's 305. Let's push this to 200, 290. Enter. Now, I think the code is ready. We can go for the simulation. Start the simulation. Well, when I press the first push button, you will hear this sound. The second, come again on the first push button. The second, you can hear that the sounds are not real same as the first one. Click on the third push button. The fourth push button. The year is the sound is slightly different from each other. What's wrong? What is wrong? I didn't hear the 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 third push button. This is okay. Let's go and troubleshoot our code. This is 1, 2, 3, 4. Okay, this is pin G return. This is 7. This is 2. This is 3. Okay, G return pin. We play the speaker with okay, what's wrong here? I don't know, but I think something is wrong here. Okay, let's start again the simulation. Press this button. There is nothing. I saw the mistake. Oh, sorry. Here is connected to this pin. Yes. Ooh, sorry. This is not very nice at all. Oh, sorry. Okay. It's not. Yes. So start the simulation again. Press on the push button. The sound. You can hear the sound. Press again. Okay. Let's do quickly and hear each sounds. This is too fast. This is slightly long. This is short. This is middle long. Let's add something more. We're going to say this is, for example, 90. This is 150. This is let's say that this is 370, and this is let's say that 300, just 300. Very good. Start the simulation again. Click on the push button. The song is more longer than the previous one that we made. This is very, very long. Try. This is short, not very short, but short. This is long, but the most long is I think this is for the this is 150. This is very, very, very long because this is 370. Click on this is 300. The most short is the first one. This is very short. After that, it is this. Okay. What is going to happen when we press the push button and don't release very soon. Ah, okay. Release, press. Okay, start the simulation. Very good. So I hope that you have learned something new, something uh, uh, very new, and something more smarter. So please, uh, don't forget to like the video, to comment, and subscribe to my channel. This will really help me, and this will encourage me also to make more better and better video. So see you soon for the next project, and keep going on, keep starting, and you will make a very big progress. See you soon. Let's learn how to use multiple potentiometers to change colors on an RGB LED. This is a project that I never done at all. So we're going to discover it together in this part of the video. Let's go click on create circuits as usual. Uh, Change the name of your project. Here it is uh, RGB lamp with potentiometer. Inside. Drag and drop quickly an Arduino and the breadboard. Let's reset the let's rotate with the Arduino. Okay. All right. Very good. Right. This this is GND. Uh, this is a GND. It is going to be connected to sorry. Uh, my screen is so small that I can see. Okay. What I'm going to do is very simple. Mm, uh, this doesn't work. Okay. Add connect the GND. This will be 5 volts. We connect it to digital pin. This is a 5 volt. This is the GND. You're going to connect it to the minus rail of the breadboard. This is black, and this one is red. Oh, okay. Let's do the same thing here. Minus rail, black. After that, this is the positive rail of the breadboard. Right. This is not beautiful at all. Okay, nice. Now, let's add 3 potentiometer on the circuit. This is potentiometer, another potentiometer, and the third one. Okay. Right. Very good. Let's add uh, RGB LED. Where is it? It is here. This is the RGB LED. We should add a resistor. Let's rotate it. Right. This is this is a resistor. Let's add right. Let's connect this is the GID terminal. We're going to connect it to this VGID pin. This is VGND. We're going to connect this GND to this one, this GND. So this GND, and this is going to go here, and this is a pin VGND. Let's change this color. This is black. This is also black. Black. Right. Very good. This is the GND of the LED. Let's connect it to. Let's connect this GND here. Okay. Very good. This is the positive LED of the. This is the positive LED. This is the positive LED. Sorry. This is. This is the positive LED. We connect it to the plus of the right. Okay, let's connect this again to the other this is what this is plus. Okay, this is plus. This is plus. This is the red is connected to digital pin. Red is connected to digital pin. Red it is connected to digital pin. Let's put it here. We're going to raise this. Okay, this is the red pin. It is going to be connected to digital pin. Digital pin number digital pin number 11. the cathode, the negative light is already connected to the ground of the prepar. Here the positive the blue, what color is it? The blue is connected to digital pin number 10. This is the blue one. And the last one, the green, is connected to digital pin number 9. Okay, very good. Okay, let's change the color of soil. This is obviously this is green. Well, after that, let's add let's connect it. This is the analog pin. You're going to connect it to E0, analog pin analog pin A0. This is right. Okay. The second one, this is the red one. The second one, this is this is going to be connected to generator pin number to generator pin A1. Let's change the color. And the last and finally, this is going to be connected to generator pin number this is what A2. Sorry, this is A2. This is digital pin A1. This is digital pin. Sorry, this is analog pin A2. This is analog pin A1. This is analog pin A0. Let's change the color of this last one. This is blue. Very good. Now that I think the circuit is ready, let's go for the code part. Okay, we're going to move this to the bin. Let's put this to the bin. Well, as start by the four-viewer block, set pin. Let's create 3 variables. This is the green. This is the blue, and this is the white. Right. Very good. Now set pin number set pin number 9 to pin number 9. Set pin number 9 to green. So set pin number 9 to green. Set pin number 9. Pin number 9 to green. After that, set pin number 10 to what? Pin number 10 to blue. Okay, sorry, pin number 10 to blue, and the pin number 11, pin number 11 to red. Okay, after that we're going to read the input of each resistor, or sorry, of each potentiometer. So those are input. So okay, set uh, set pin. We're going to make a comparison. Not a comparison, an operation. This is read digital pin, read analog pin, sorry. This is the input. Read analog pin is 0. We're going to divide it by a value which is 4.0158. Duplicate this. Sorry. Let's move this to the bin. Okay. We need to duplicate this variable. Duplicate this. Duplicate this again. Very good. Place this here. And this here. This is the red one. The red one is reading on digital pin A0. The green is on digital pin A1, and the final, the blue, is reading on digital pin A2. Very good. I think the code is written down. We can go for the simulation part. Click on Start Simulation. You don't need to add more resistor for each leg of the LED, because those potentiometer are some kinds of some resistor are some kind of resistor. So we don't need enough resistor for that. So when we change this and we change this and we change this, I think this is the green color. This is what? This is what color? This is another color. This is which color? If we put this here, there's nothing. Here there is nothing. But I think it should be this is what? A0 digital pin software simulation part. Okay. This is where the mistake is. We didn't change this. So start again the simulation. I think this is going to work now. This is the red color. This is the red color. Okay. The LED is red because the other two potentiometers are at 0, 0. But when we change each value, we can see that the resistor take the LED is set to another value. This is the purple, I think, or the pink. I don't know. It may be the purple. Okay. This let's search for another color. I think this is the orange one. What is this color? Okay. Oh, that's pretty. Nice, a good project, I think. We have every type of color here. Ah, this is the blue. This is the this is yellow. This is green. This is what? This is always green. This is green. Mm. Blue or green. Mm. Uh, so this is how you can change uh, the you can have multiple color with the LED with the RGB LED and using three potentiometers to have any colors of the world that you want. I think really this is a really good project that you can reproduce at home and learn from it. So you can change any value that you want. But I think you this is an assignment for you at home. So see you for the next time, and we're going to learn from uh, another project again. See you. Please don't forget to like, uh, to subscribe to my channel, and to share this video to your friend who want to learn Arduino simulation on an online platform. Uh, don't forget to put also comment to encourage me. As you know, I'm not a native English speaker, but I'm doing my best to speak English. So see you soon, and don't forget to support me by liking this video. See you. After two big projects, we're going to do something simple, very very simple. So create circuits. Uh, this project consists to simulate forces with a force sensor. So we tap force sensor. Uh, this is going to measure a value in Newton. So Newton is a measure used traditionally in physics, mainly in mechanical engineering. For example, if I tap uh, Archimedes, if I tap Archimedes principle, if I tap this Archimedes principle, you will probably have uh, something like this, right? For example, Archimedes, this value FB equal to F2 minus F1, or the general the way formula is FB equal to rho F J V. The value of the VS, the force is measured in Newton, and we can use a force sensor to measure this value. It is also used in gravitational interaction. It is also widely in gravitational interaction. Uh, the gravitational interaction is a discipline which studies how planets move around the moves on the world on the universe, and what are the action each planet have on another planet. So this is one of the field of physics. Uh, in, we can study planets in the world. This is gravitational interaction. You will study this at university for those who are in a specific uh, who choose a specific subject you're going to start at this at college. So let's go and make some simple connection with what we have. Also, let's drag and drop a resistor to not, of course, damage our sensor. Drag and drop a resistor, connect it to this terminal. This is the GNT. This is connected to GNT. Yes, black. And this is uh, the positive pin connected to 5 volt. And this is uh, uh, an analog input. It is connected to digital pin. Sorry, it is connected to analog pin A0. Let's change the color to maybe yellow. Go to the code. Delete this block. Again, this block. Control for river. Sorry. Okay. Uh, let's read. Yes, let's read the value printed on the serial monitor. This is an output. Print on print to serial monitor. We read what? We read an analog input. This is read analog input. It is at digital pin. Sorry, it is at analog pin A0. Okay. Start the simulation. Right. I think there's no issue here. As you can see, this is 5.667 Newton. This is 1.38 Newton. I think right now you can see the application. Maybe you tap on Google and you make a small research on this sensor, but it is very useful for it is very useful in many projects. So it is really good to test some on the Autodesk or Tinkercad platforms. I will leave you soon, and please again don't forget to like my video in order to support me and to encourage me making enough video. So see you soon for another project. Let's go again for a very simple project again, which is how to use a mature sensor. Click on create start second story. Rename your project, use uh, master uh, sensor and so on. The master sensor is widely used in agriculture firm and in research firm. It allows us to measure the dryness of the soil, to take decision and give data to our circuit, or let our circuit know if you have to do something. For example, we use measure sensor in projects related to agriculture firm, like watering plant. After receiving that uh, the soil is right, we can use it in the gardening, in a type of gardening session or automation plants whenever in farming. So let's add an Arduino video. Uh, uh, we're going to use a DC motor. This DC motor is going to be connected to the GNT of the Arduino. This is the GNT of the Arduino. This is sorry, this is what? This is the power, this is the ground, and this is the signal. So this is connected to, this is what we power. This is going to be connected to uh, so to 5 watt, of course. This is going to be connected to 5 watt. Okay, let's change this color, and this is obviously black, the GNT. This is connected to generator pin number 2. Let's use the yellow, no, the green color. This is connected to the ground, the GNT of the Arduino. This is the GNT of the one of the GNT of the Arduino, black. And this is the signal which is connected to an analog, to a digital, sorry, to an analog pin A0. This is connected to analog pin A0. This is yellow, white, very good. Now let's go for the code. Here we want, for example, to measure the dryness of the soil. We want to say, we want to give to the circuit that at a certain level of dryness, if dryness equal to, for example, 300, we want to water our plant, or we want to give light to the plant. So let's move this. Sorry, this is what, or is it? Okay, to bin, to a bin. Okay, this is to bin. Right, very good. Now we want to add an if-else statement, because if the soil is right, we need to water the plant. Else, so we have to put a math comparison. This is we want to measure the level of dryness our plant by reading the analog pin setting to A0. Well, we need to set we need to set pin the output pin, set pin to higher, and then set pin to low. As you may know, the the DC motor is connected to generator pin 2. When the soil is right, we need to activate the file on generator pin number 2. We will put it at high level, and otherwise, if the soil is not dry at all, we're going to set it at the low level. So let's start. the let's start the simulation. There is one why maybe we didn't add a resistor to the circuit, but okay, where is the issue? We're going to damage the Arduino. This is not a good practice at all. But if you zoom with my screen and start the simulation, we can see that at some certain level, start the simulation. As you know, the soil is wet, but here there is not enough water. So okay, here the soil is right, but when we increase the value, the soil is wet. So we don't need to turn on the fan of the circuit. When we is here, the soil is dry. But when it's here, the soil is wet. Again, dry. So we turn on the fan. This means that we are watering our plants. But when it is here, the soil is wet. The plant don't need any more water to survive. So this is how to use a moisture sensor to measure the dryness of the soil. So see you soon for the next causes. Let's learn how to make a beginner simple project simulation on Autodesk Tinkercad. And this time is for how to use ultrasonic sensor. So click on create circuits. We need to rename our project as usual. This is use ultrasonic sensor. Quickly drag and drop an Arduino since we favorite board. I don't know if it is okay. Remove this. Let's add ultrasonic sensor, and then let's add an LCD. LCD. This one could be better. Okay. This could work. Yes, this could work. When let's make connection with our jumper wires. This is connected to the GND quickly. Black. This is VCC. VCC, it is connected to 5 volts. 5 volts. Okay. This is SDA. SDA, it is connected to what we call, this is SDA. It is connected to, I don't know, this is what GND. This is SDA, yes. This is SDA. We can set the color to green, for example. This is SCL. It is connected to, what is this? This is SCL. It is connected to, the last pin here. You can change the color to green. Very good. This is the ground. It is connected to sorry. Let's change this ultrasonic sensor. I don't want to use this. What is about this? Okay. Another ultrasonic ultrasonic. I see it happening to my mouse. Okay. I think this is better. Yes, let's change this. Okay, very good. We can connect this to 5 volts because this is VCC. Anywhere that you will read VCC, it is 5 volt or 3.3 volt. Let's change this color. This is now we connect this to, this is what T. This is a trigger. We connect it to let's say analog pin, digital pin, sorry, number 2. This is going to be wait. This is the echo is going to be connected to digital pin number 3. Yes, of course. Okay. This is my brown. And the last one, this is the ground. It is connected to ground. Let's change the position. Okay, very good. This is black. Don't forget that. After that, let's go for the cloth. Delete this. No. Delete this. So on start, we're going to set the position of the LCD. So there is a block related to that. This is print to LCD. Yes, very good. Print to LCD to, I think there is another thing. Print to set position. Yes, set position to the LCD position 1 to column 0, 0. Print on the LCD. We're going to print on the LCD. What is going to print on? Hello world. Hello world. Let's set the position. Let's duplicate this. Okay. Duplicate this. We're going to move this to the bin. This to the bin. Okay. This. Very good. Let read ultrasonic input. This is with ultrasonic distance. At what position? At pin number 2. Echo in pin. So we read here at pin the echo is connected to digital pin 3. and the trigger is connected to digital pin number 2. So the trigger is connected to digital pin number 3, and the trigger uh, so the core pin is connected to digital pin number 2. Sorry, digital pin number 3. Very good. The unit is in centimeter. I think that no, let's change this value. This is 1. Let's set 1. Okay. Start simulation. Let's go what is going to happen. Hello is pretty on our LCD. So this is how to print on the LCD. Okay, here is where we are. When we change the position, you can see that the LCD writes a number. When we here, we have another number. When we are at this position, we have another number. So this gives the distance from where we are from the ultrasonic sensor. This means that if you are a visitor or someone who is coming, who is going to enter to your home, you can see at which distance it is, or you can go quickly to open the door before a ring the ring you. So I think this is all for this small project. I hope that you have learned some things more, and see you soon for another project. Please again, don't forget to like, subscribe, and comment. This will support me, encourage me to do more, and more videos. So see you soon, and I wish you a best journey, a nice journey. Sorry, I wish you a nice journey. Let's learn how to use a servo motor. So circuits as usual. Rename your project rotate. So rotate servo motor servo motor sensor. Enter. Drag and drop an Arduino. The same thing with servo motor. Okay. This is what? This is the GND. This is the power. This is the signal. Right. The GND, the ground, is connected to this is what the ground. The ground is connected to the GND of the Arduino. It is connected to the GND of the Arduino. This is black. This leg, this pin, the power is connected to 5 volt of the Arduino. 5 volt of the Arduino. Very good. Yes, you go. Wait. And the final one, the signal. It is connected to digital pin. Let's say digital pin number 2. Okay. Let's change this color to let's say green. Open the code block. Okay. Let's move this. And now let's say that we want to wait our servo on digital pin number 2. Let's set rotate. Where is this code? Where is this block? Rotate our servo motor. So rotate it is on digital pin number 2. The decrease is going to be, for example, 170, and we wait another, we wait until again the servo uh, to make 2 seconds, and again we waited the servo motor. We're going to duplicate it. It's going to be uh, digital pin number 2, but this time is, for example, 130. We can make this process again by duplicating it, and this time we're going to we're going to move for 0 degrees for 2 milliseconds. I think this is all. And we can start the simulation process. This is the first rotation, the second, and the initial position. The first rotation, the second, and the initial position. Uh, I think this is all. This will allow you to close or to open a door or to make something else. Uh, so thank you very much. This is the last and the final tutorial for the beginner level. The next time we're going to do something more bigger. This is the intermediate level. So see you soon. And don't forget to support me by liking this video, putting comments, and show me what you would like to learn in the future. See you soon. Now it is time to build intermediate project. We're going to blink multiple LEDs by writing code on the text editor. So first of all, change the name of your project. We're going to call it blink LEDs, LEDs programming. This means that we're going to make our own program. Insert. There we go. Draw a driver and an Arduino Uno. Display them on the workspace like this. Connect the two things, the GND quickly. Connect the GND. Sorry. On the 5 volt to the 5 volt to way plus of the breadboard. Let's change those color. This is red and this is black. Do the same thing here on the side of the breadboard. Okay. This is literally black. And this is red. This is what I've done. Okay. Let's change this. Let's change this to that. And this. Okay. Very good. This is black. And this one is red. Drag 3 LED. 1, 2, and 3. Add resistor. Connect them. Let's change the color of the LED. This is red. We're going to leave it at red on red. This is green. Green. And this last one is blue. Okay, connect the legs of each LED to the Arduino. Sorry. Okay. This is connected to digital pin number 10. This is digital pin number 12. It is red. Sorry, wait, and this is digital pin. This is digital pin. This is blue. Very good. Open your code. Open your code. Text. Continue. By default, this is a program to blink one LEDs, just one. We can very good. As you can see, the red LEDs just with the red LED is blinking. This is a program for a single LED, but in our case, we want to blink multiple LEDs. So start the program, and what I'm going to do is to create constant. Okay, we're going to say that this is const int. That means it is an integer. We have a red LED, so red pin equals to the pin number is 13. Const int green pin. It is the green pin is connected to digital pin number 12, and const int blue pin is connected to digital pin number 11. Okay. Here, let's remove this. This is where copy this and pass it here. Okay. This is pin mode. We're going to copy this. Do again. Wait. This is we're going to copy the green pin. Pass it on the second. Copy the blue pin and pass it here. Very good. Let me zoom it on it. Well, we're going to delete this. Oh no, we can use it. We're going to come back. Okay. We can say blink the red LED here. This is the red LED, so we're going to change this. This is red pin, and this is red pin. Okay, we're going to copy this and make it this is a green pin. This is the green pin, the green LED, sorry, and this is the blue LED. This corresponds to sorry. Okay, yes, this is green pin. We're going to pass it out away here. This is green pin. The same thing, the blue pin. The blue pin. The delay time will remain the same for each LED. I think the code is now ready. We can simulate it. start simulation. Very good. As you can see, the LED are blinking regularly uh, with a delay time equal to 1000 milliseconds. This is just 1 second. So this is how to create a program, or this is how to write a code instead of using code block to let LEDs blink. This is the first method, but we can have another method. Uh, the code will be very simple, not long, like this. So we can comment this line. We can make comment. This is the pin of the red LED. Okay, this is the pin of the green. Sorry, this is the pin of the green LED, and uh, and this is the pin of a blue LED. Here we take we read the output, and here we turn on. This means that the I means that uh, we turn on the LED, turn on an LED, and the low value means that we off turn off an LED, and that's same for the other part of the code. But now I think that we're going to make something more clear, very simple. We're going to do like this. We're going to delay this. No, like this. We're going to delay this, and we're going to delay this. Okay. So we did the first method. First, we did the first method. But now let's go for the second method. Okay. In this method, we're going to use a loop. This is the for loops. So for the pin number are ints. So int I equal to, here we start by digital pin number 13. So int I equal to int I equal to 13, and the digital pin stop at pin pin 11. So I is superior to 10, and we go from digital pin number 13 to digital pin number 11. So we decrement the value of I. So I is minus. Okay, we want to wait each digital pin. So our pin most I output. Very good. Now I'm going to do the same thing with this. Okay, let's copy this part of the code, put it here. Okay, delete, copy this. Oh, sorry. Oh, we need to take this. Oh, let's go on. We need to take this. Okay. I don't know. Mm, okay. Here we want to wait the I. We will write on digital I, a digital pin number I, and here the same thing on digital pin number I, and then uh, we close our loop function. So I think things are very good. We're going to see we simulate our program. So start simulation. Ah, there is a warning here. What is on our input function? Mm, what's the mistake here? Okay. Uh, in function voice setup. Output. Oh, okay. Je n'ai pas petit. Start again the simulation. Okay, and things are working properly. This do the same things uh like the first method, but the code is really simple and efficient. So we don't need to write those lines uh multiple times. Just a loop on the voice setup and void load functions can do the work. I hope that you enjoy this part of the tutorial. So let's go for uh, a more proficient project. This time we're going to build a smart home. Well, this time we're going to build something more bigger, something more smarter. This is a room lighting system. What is the purpose of this project? This type of projects save energy. It allows us to automate our homes. It is comfortable. We we have we can use it in garage, bathrooms, or or any other types of allies. So change the name of your project. Uh, room room lighting system into right. To be that kinds of project, you just need a motion detector, uh, a light, a supply power, relay, Arduino Uno, breadboards, um, uh, I don't know, maybe something more. But let's go to build our circuit. We start as usual by uh, those two things, our breadboard and the Arduino. Connect the GND and the 5 volts of the Arduino. This is black, this is red, and this is black. Okay. Uh, this is black, the GND, and this is red. This is this is red. Okay. Um, let's choose a motion detector. uh I don't like this position. Let's rotate it. uh let's add uh, a relay. Search here relay. To this relay, drag it and add a light. Search for light. I think this position is correct. Add a power supply. Power supply. This is the power supply. Okay, very good. Now let's go to build step by step our circuit. Something is missing. This is the, I don't know, I forgotten its name. Photoresistor. Ouais, I think this is photoresistor. An LED to not damage our photoresistor. Okay. Where should we, where we going to start? Where we going to start? Let's start on the whiteboard. Okay, just connect one leg of the photoresistor uh to the positive way and connect other leg to GND. This is black. The second thing is to connect the motion detector. This is the signal, this is the power, and this is the ground. Okay, so this is the ground. We're going to the minus way, and this is the positive. We connect it to, and this is the signal. We're going to connect it to let's think to digital pin to digital pin number 2. Let's change the color to red. After that, let's go to connect uh the light. The light is connected to a power supply on the to a power supply like this. This is black. And we connect the power supply. So the relay. Okay. Let's connect this to this terminal. Okay, very good. And the relay is connected to the minus rail. This black. Well, after uh, after connecting the relay, we're going to connect the we we didn't done with the photoresistor. We're going to connect one leg of the photoresistor to analog pin number A number A 0. This is green. And what else? One leg of our relay is going to be connected to uh, the digital pin number 8. Mm. What else again? Do I forget something? I don't think so. Okay. Show me if you can um, detect the mistake here, please. Don't forget to comment under the video and propose yours on method, please. Mm. We're going to troubleshoot. Let's troubleshoot our circuit. Uh, I think everything is okay. Uh, Everything is okay. Maybe. I think so. Do you think so? I think everything is okay. Yeah. Uh, so let's go and program uh our circuit. Mm, we don't need this, and we don't also need this. I'm going to explain you quickly uh the method. So what's going to happen? The light sensor will read if there is light or not on the room. This means that we can use the sunlight or the light provide or the light provided uh, by the users on their home. If the light is turned on and on, Arduino, the Arduino controller should know that. And we use the motion detector to see if there is something coming to the room. If someone is coming to a room and the room is dark, we turn on the lamp by supporting the lamp by the power supplier. If uh, someone is coming and the room is light, it is not dark. If the room is not dark, but there is the sunlight in the room, the lamp do not turn on. It's going to stay off. So as you can see, we can save energy by using this system and control it at distance. If we forget to turn on the uh, the the light, we can use it this type of system to to turn on or to turn off the refrigerators or other things in the room. This is the flowchart of a process. Okay, I'm going to explain you again. We read the brightness of we read the brightness of a room. Is it dark? If it is dark, if the room is not dark, we turn the light off. But if a room is dark and if someone is approaching to a room or is entering to a room, we turn on the light. Otherwise, if the room is dark, but there is nobody coming in that room, the room the room will stay um, the the uh, the light will stay off because there's the room is dark, but there's nobody on the room. I think you could understand this. Okay, this is the same process. Uh, I think this is on. Uh, I want to show you again. Okay. Uh, let's go back uh to our to our platform. We're going to make a simple program. So we're going to initiate uh, uh, the pin of our sensors and light and other things. And so this is int uh, the light value, the light value equals to is receive the 0. This is an input sensor. The second thing is to initiate int the per var equals receive to 0. This is an input again sensor. After that, we will initiate the relay. So int relay output is initiated to 0. This is the this is the relay. The relay. In the loop, in the setup function, what we're going to do is to run on the program. We want to wait the we want to wait the analog pin here. So pin mode E0 A0, and this is what this is an input. This is an input. We wait the LED. We wait the LDR sensor value. We will wait after that. We will wait also the motion detector. So this is pin mode 2. Sorry, 2. This is also an input. This is we wait the motion detector sensor. Okay, this is pin mode. Now it is what? It is pin mode. Pin mode. What's going to wait? Let's see that. This is pin mode. Pin mode. This is digital pin number 8. Digital pin number 8. Let me zoom. Okay. This is digital pin number 8. This is for the. This is an output. This is an output. This is. We give value. We bring value. So bring value. So the relay. Okay. I think this is all for the setup function. Let's go now for the loop. In the loop function, What we're going to do is very simple. We're going to do something very simple. This is uh we need to wait the analog value. So light, uh let's copy this and pass it here. We want to wait it. So with analog with A0 and here val. Let's copy this. This is a digital. We want to wait the digital uh with digital Q. But we don't need the relay right now. So if the light is if a light value is inferior to uh, let's say 500, then we're going to do what? We're going to verify if the motion detector has detected someone approaching. If someone is coming on the room, or sorry, in the room, this means that the value of this sensor is going to be high. Okay, so we verify if this value is high. If this is true, we're going to turn on. If this value is true, we're going to write. We're going to write. We're going to write. We're going to turn on. Sorry, we're going to turn on the light and wait maybe 400 milliseconds. For example, 4,000 milliseconds. Yeah, this means that we wait for 4,000 milliseconds. Okay. If the pair val, if the motion detector has detected someone, we turn on the light. Else, if not, this means that if the uh, the motion detector hasn't detected someone, we turn it off. The light is turned off, and we wait, for example, 1,000 milliseconds before we continue. This means that wait for 1,000 milliseconds before we continue. Okay. But if we didn't read anything, if there is nobody in the room, we will turn again off. We turn off again the light. So serial println light value copy and paste this. We wait for example 300 milliseconds. Wait for 300 milliseconds. Okay, I think that's all. Right. Do we forget something? Yes. We didn't say that we want to start very don't forget that. Okay, that's all. Survey simulation. There are some issues here. Digital. Oh, this is digital white. Sorry, digital white. Are there issues here? Unable to contact the code compilation service. Please try again later or contact us if the problem persists. I think there is something wrong on in the circuit with the circuit. Let's try this again. I think there is something wrong with circuit. I don't know where is the mistake, but we're going to troubleshoot our circuit. Let's start again the simulation. Maybe it will work again. Okay. Okay. There is any errors, but nothing happened to a light. Ooh. Stop. Let's come on the circuit. This is correct. I think this is correct. This is correct. Any mistake here? There is no mistake here. This is good. This is good. This is good. Correct. Correct. This is what? This is correct. As you can see, we connect here. This is the problem. Okay, we connect the GND of the sensor to 5 volt. So we connect the GND of the sensor to 5 volt, but this won't work. So let's change this. Okay. I think this is going to work right now. Maybe if there aren't other mistakes here. So try and try again. Let's go in. Let's go in. Okay. Very good. It's working. It is working. What we can see here, it is working. Let's change this value. It's still working. Okay. Let's change this. There is nothing yet. Okay, pretty good. So, uh, this is how to build a room lighting system by yourself. Don't worry, I'm going to put the links of my circuit in the description of the video. I will also give you the code so that you can learn from it. Let's start the simulation. We can put a lot of comments that um, uh, you can comment mailing line, sorry. This type of comment is for multiple line. This is this is a room lighting automation system. What is its purpose? Uh, what are purposes for this type this type of project? There are many purposes, but it only has to save energy, to be comfortable, and also to automate our home. The purpose is that it allows us to be comfort. It also has to save energy, so save energy, and also it is an automation system rather than uh, the usual. Why people build this type of the system? It is convenient. Also, why? Why it is good? So why it is good? What's good for people? What is good for people? This is because it save electricity, as we said here, save energy, it save electricity. It is convenience for we don't need to switch. We don't need to click on the switch uh, every day, and it is useful for alleys, bedrooms, storage rooms, bathrooms, and stairs. So it is convenient, very convenient for the convenience. It is safety. It is safety, and also uh, it is really uh, uh, it is accessibly for that area and for elderly people who can stand up to turn on and turn off the light by using the switch at home. So it is the accessibilities. It is really the accessibility, and it is a way project for the to be introduced. It is really a good project for to IoT and home and for and also to learn automation. So I think this is all for this project. See you soon for another big project. I will put this code on the description of the video, and I will also give you my link for this uh, of this ticket card. Sorry. Um, as an assignment, I should propose you to create an app that will control this uh, with your phone. If you are using Android or iPhone, you should build your you should build you should build it by using hardware and control it via your phone. This is this by this way you will develop a very good you will be a master on Arduino building and Arduino circuit building and Arduino programming. So see you soon for the next for the next project. Don't forget to subscribe, to like, and to comment on the my video. See you soon. Do you want to go on vacation, to go on holiday, or to take part to a party, but you are worrying about your plants, your gardens, or your farms? So don't worry, I have something for you. This is a plant watering system. How does it work? What is its purpose? And when, why to use it? So the main purpose of this project is to automatically monitor and maintain the moisture level of soil. That's why we use the soil moisture year. This helps us to ensure that the plant receives the right amount of water without a human intervention. The system, as I told you, uses a soil moisture sensor to detect how uh, how wet or dry the soil is. It is based on reading. The Arduino controls a water pumps. So the Arduino control um, a water pumps uh, and LEDs, buzzer, sorry, uh, buzzer, a LCD where on which we can on what we can print something. This help us uh, to display water to display water to the plant when necessary and to notify the user that it's time to water the plants or not. What are uh, if I can say like this, what are the main purposes of this type of projects? So there are not one, there are main purposes for this type of projects. So it can be used uh, it can be used to for many things. This is the main offer. I took this project on the internet, but I'm going to maybe to add something. Don't worry, uh, I will release this code on the description of the video, but don't forget to save the offers, the initial offers, and if you can to add your modification or to bring something new to this project. So what are uh, the key purposes of this type of projects? There are many, so many, but we can say that one of these key purposes is that uh, it maintains plant health. It helps us uh, maintain uh, plant health. It can allow us uh, uh, to so for maintaining plant health, it will ensure that the plant gets enough water to grow properly without any human interventions. That means that there is no over-watering and there is no under-watering. The plant is watering uh, as well as it needs. So the second thing is that these types of projects uh, can help us to automate routine. So it is good for to automate uh, routine uh, routine plant care, for example. Uh, It is really good for people who are really busy. They don't have time to come back because the 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 they are working, for example, and they don't going to come back at home. It is also suitable for offices because uh, we we really don't want to have some things every day to bring pumps or waters the plant. So no, it is suitable for offices. Uh, it is really used by students and colleagues. It is really used by students, papers, and sometimes children. So it is good for schools and labs, and lab projects. It help also uh, elderly people because as you may know, they are old. They don't have the own mobility to water the plants. So this uh, by using an app, they can decide whether to water the plant or not. The first thing is that they save water and resources. They save water and resources. This means that the pumps activates only when the soil, when moisture, when soil moisture is low. This allow us to prevent water waste. The another, the another uh, thing is that it improve accuracy, improve, for example, accuracy. Moisture sensors detect the soil condition better than guessing by hand, uh, giving more reliable plant care. It is also used for educational purpose, as I told you, uh, educational, uh, educational purpose. Uh, this project is widely used to learn Arduino programming. Learn Arduino programming, for example. It is used to learn Arduino programming. It is also used to learn how to use sensors on electronics components. Uh, use how to use how to use sensors on hardware together. Right. Uh, where we can use this type of projects, um, where we can use this type of project, where to use this project. I'm going to say everywhere. It is also suitable uh for for example for smart agriculture. For smart agriculture, it is suitable for uh, uh, greenhouse because we need to control vegetation. This also this also suitable to greenhouses for uh, for offices for offices uh, schools on public spaces and public spaces. Uh, it is also widely in it is used in research field. It is widely used in research fields, and it is also used to build, to teach uh, IoT for IoT courses. So, uh, uh, in a few words, the automated plant watering system automatically measure soil moisture and waters the plant when needed. Its purpose is to ensure healthy plant growth. It also saves water, reduce manual effort, and demonstrate basic IoT and automation concepts. Uh, this system is what they use in home gardening, for small agriculture, for greenhouses, for laboratories, and also for educational environments. Uh, so I think we have talked too much. Let's go for a simulation to see how this works. Start. Right. Automated plant watering system. Ah, as you can see, the measure indicates that the 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 plants need to be wetter. So uh, at this level, this means that the soil is really dry. It's very dry. But we're going to wetter the plants. The plants. Uh, it's not really watering at all. But we need to wetter it again. And when we are below 50 percent, this means that we're still watering. We need to water again. At 68, the buzzer stop raging. This means that uh, the plant, the waterway system stop the plant. Uh, don't need uh, to be watered anymore. So this allows us to know the exact amount of water that uh, a plant, a farms need. Okay. Stop simulation. I don't know if there are something else to show you, but as you may know, I will release this. I will release this. I will relay this code, and I will give you also the link of the project. I will put it on the description of the video so that you can try at home. You can study properly the code here. You can see what is going. You can enhance it and build your own uh, uh, plant watering system at home. So the see you for the next projects that we're going to describe together. Do you want to secure your home, your apartment, your offices, your money, or your garage? This is the right place where to do that, where to learn to do that. Combinations block. Combination blocks have been there for decades, and many products such as briefcase doors are protected by them. There is keypad module for Arduino that can help us to set combination block password for various things. You may use, for example, RFID cards to provide access. In this tutorial, I'm going to explain how you can make push button combination block. This project will help us to set combination password, and you can set password by using 1 to 6 digits. When you will push, when you will push, sorry, the push button. When you will push the buttons on the combination is matched, the green LED will be turned on, and if the combination is not matched, the red LED will indicate that the password is wrong. So don't forget, when the code match the green LED will be turned on. Otherwise, the red LED will be turned on. The red LED, green LED turned on. False. Uh, the red LED will be turned on. What is on the code? So let's go and look at. Here is the code. It is 6, 5, 4, 3, 2, 1. So let's go for our simulation. Uh, we start by what? We start by 6, 5, 4, uh, uh, 3, 2, and 1. The green light is turned on. This means that the code is correct. But let's try another code. For example, this, 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 or this, and this. The red LED is turned on. This mean that the code is false. The password is false. Sorry. Uh, let's change the code. No. Uh, I think that's all. So this is the secret. Uh, I will put it on the description, and I will give you also the code to copy and paste it at home or on your Tinkercad uh, platform. This will allow you to test the code and to learn more advanced things. This is an advanced project, so you can do it at home by yourself. Learn what is going on when you do that such kinds of thing. So I think this is all for this project. See you soon for another one. You are busy, or you are on the way to go out, or you have an appointment, and you have also your pet. This could be a cat, uh, or a dog, and you need to feed those pets, but you don't have enough time. Don't worry, I have something for you. This is a feed pet. A feed pet feed uh, uh, so pet feeds. So uh, so uh what is a pet feeder? A pet feeder is a system. It could be manual or automatic, but that stores food and releases a specific amount at a scheduled times. It can be simple, advanced, depending on the design. In our case, this pet feeder is for an advanced project. So, what are the purposes of a pet feeder? It ensures that a pet eats on time. Uh, it controls also food portions. It is also useful for pets on diets, and we can it reduces owner workload. It's also good for forgetful or busy owners if you are on vacation, or you went out uh, among your friends for a party, or if you at holiday for 2 days and you don't want that your pet follow, or you don't want to go with your pet, you can use a pet feeder. Where are a pet feeder used? Very simple. Pet feeders can be used at homes, uh, for at pet shops or animal shelters. Uh, m- Veterinary clinics can also use pet feeder. Hotels or pet boarding centers can use pet feeder. It is also used for research or in research labs. Feeding animals at exact intervals for experiments, for example, to see how they can react uh, when they feed at this time, not that no, at this time, rather than those times. So there are many examples of fed feeder. We can do it with an ESP32. But in this project, we use the Arduino. What are the hardware that we use? Not much at all. We use, as you know, an Arduino Uno, a breadboard, a push button, uh, a servo on uh, some LEDs and resistors. So uh, let's go and simulate the projects. Okay. Uh, when we press the button, this means that the Fet is hearing. When we continue, this means that we continue releasing the food on the for the pets, but then uh, the LED are turned on uh, all together. This means that uh, we have finished feeding the pet. So we can close or we can turn down or we can turn off our pet feeder to not waste this will allow us to avoid wasting uh, food, so we can turn down uh, our pets. I think this is all for the pet feeders. Now let's go for the next project. So please don't forget to support me, like my videos, subscribe uh, if you haven't already. Uh, I promise you that I will release all the projects, the colors, the seconds on the descriptions of the video. So see you soon, and uh, let's keep in touch. Do you want to secure your home, or do you want to avoid wasting energy at home? Here you are at the right place. This is a password access control project that you can build at home by yourself at your own pace. So, how does this work? Very simple. There is nothing hard at all. Let's go for the simulation part. When you arrive at home or at your room, at your bathroom, you need to enter a code, a password. Years in this example, the code is 1, 2, 3, 4. Then, when the code is correct, the door is unlocked. This means the door is open and the light are turned on. This is a great project. This is an expert one for engineer level that you can try at home if you feel confident with Arduino programming and Arduino simulation. Don't worry, I will put this code and this circuit uh, in the description of the video by citing, of course, uh, the original person who made this project. So let's go for another simulation that I will show you what you can try at home and what you can build at your own pace with an Arduino and with some software that you can have at your own pace uh, uh, on a DIY market. So see you next. Welcome to an advanced, even if I can say an expert uh, Arduino programming project. This is this video will show you how to build uh, an access control in front of your home, on your apartment, or your garage, or everything you want, an office, a building, everything that you want. So how this project work? I'm going to show you quickly by making a simulation, a short simulation. So here, the password is let me show you. Here it is. The password is 1 1 4 times. So let's go for when I type when I type 1 1 1 1 and I hit the letter D. Then you have correct password door opened. Okay, but if I enter another password instead of 1 1 4 times, let's go to see what's going to happen. Uh, Hit the button. Uh, One password, please try again. So this is how you can make you can secure your home when you are starting at home and you don't want to be disturbed by anybody at home. You can use this type of project to secure, of course, your bedroom. So for those uh, who love Arduino programming, who love IoT, and who want to learn more, please don't forget to follow me, to share this video, to like and to subscribe to my channel. See you next. Let's do something more, more, and more important. How to build a drone, how to make drone simulation on Autodesk Tinkercad using Arduino programming language. This is not difficult at all. Uh, we will not have time to build all these projects here, but what you may know is that I will release the circuit on the description of the video, and I will also give you the code so that you can use at home. So what I strongly recommend you is to build this project. Uh, uh, is to do it yourself at all. Learn what is going on. To troubleshoot problem and to see um what's the best thing if you can modify, if you can add, you can remove, or you can enhance this project so that it can be very more important. So I think this is all for this part of tutorial related to Autodesk Tinkercad uh, Arduino simulation and Arduino programming. Uh, Now we're going to use now the real hardware to build step by step the whole project that I've shown you since now. So let's go for the another step, a new tutorial, a new video to explain you real deeper uh, what is Arduino, what is NLT, how to build real project using the real hardware. So let's go for the next step.